Okay, the purpose of question 4.1.27 is to use cross products to find areas. Question is, find the area of the triangle in R3 with vertices as given. So first thing we need is vectors, not points. So they've given us points in R3. So let's introduce a couple of vectors. And vectors say from this point, the first point to the second point, and the first point to the third point. Then we'll draw a little picture here in a second and show how those resulting two vectors determine a parallelogram. We know how to associate the area of a parallelogram with cross products. It's the norm of the cross product. We're not looking for the area of a parallelogram though, we're looking for the area of a triangle. So first, how about we maybe write these vectors in terms of components also. First, let A be the vector from 2, 1, negative 3 to 3, 0, 4. So that vector A has components. Head minus tail, so it'll be 3 minus 2, 0 minus 1, 4 minus negative 3. So 1, negative 1, 7. Let vector B be the vector from the first point, 2, 1, negative 3, to the third point, 1, 0, 5. So that, similarly, skip a little step of arithmetic here. So we'll do head minus tail, so it would be 1 minus 2 is negative 1, 0 minus 1 is negative 1, 5 minus negative 3, so 5 plus 3 is 8. Okay, so here's what's going on. We've got those 3 points, maybe schematically. Here's those 3 points. All right, they've determined vectors A and B. So say vector A is here, and vector B is here. 3 points determine a plane, regardless of where they are. Say it's the plane of the whiteboard, so schematically this is what we get. All right, well now vector A and vector B, they determine a parallelogram. Something like this. Okay, so they determine a parallelogram, and the area of that parallelogram by theorem, I believe it's theorem 4.1.a, the area of that parallelogram is the norm of the cross product of those vectors. We don't want a parallelogram. We've got the 3 black points. We want the area of the triangle determined by those 3 points. So we actually want that area there. But no problem, that'd just be half the area of the parallelogram. Okay, so this will let us introduce an application of cross products. The area of the parallelogram determined by 2 vectors A and B is the norm of the cross product by, so it's theorem 4.1.a. So the area of the triangle, the given triangle, is half of that. So it'd be half of the norm of A cross B. Okay. Let's figure out A cross B. That would be let's see, we've got the components of A. Here they are, components of B. We want to take a cross product. We've done that symbolically by taking determinants of 3 by 3 matrices. So we'll take the IJK, 1, negative 1, 7, the components of A, the components of B, negative 1, 1, 8. We'll take the determinant of that. The little outer double vertical lines mean take the norm of. The little inner single vertical lines mean take the determinant of. So we just got to crank through the computations there. So we get 1/2 norm of. Okay, I will eliminate the row and column. Look at the minor matrix with entries negative 1, 7, first row, negative 1, 8, second row, times I. Minus, remember you get the minus, the alternating thing with the signs and this stuff. Eliminate first row, second column. That'll leave us with 1, 7, negative 1, 8 times the J vector. Eliminate row and column containing the K vector. Leaves us with the minor matrix 1, negative 1, negative 1, negative 1 times the K vector. And we need to take the norm of that vector. We okay on all the minor matrices. Eliminate row and column. That one's correct. Eliminate row and column. The second one's correct. Eliminate row and column. Right. Okay. So let's take the determinants of those 2 by 2 matrices, something with which at this stage you should have a fair amount of practice from the earlier questions. We'll have negative 8 minus negative 7. That's negative 8 plus 7 is negative 1. So negative 1 is the coefficient of I. Here, let me take that negative out front and see what we get here. We got 8 minus 7 times negative 1. That's 8 plus 7, 15. Maybe I don't need the parentheses, 15J. Over here we've got negative 1 minus positive 1. 1 times negative 1 minus negative 1 times negative 1. That's negative 1 minus positive 1. That's negative 2. Okay. All right, so let's do the norm part of the computation. That'll be a negative 1 squared. Coefficient of I is negative 1. Negative 15 squared. Coefficient of J. Negative 2 squared. Coefficient of K. Take a square root of that because we're computing a norm, and that will give us, let's see, 15 squared, 225, plus 1 plus 4, that'd be 230. 230 square root of over 2. See, 230 is 23 times 10, so I don't think I can simplify it any. So we're stuck with that version of the answer. And so there's the area. And it's computed using cross products. Kind of like this one. Ask you a question about points. You don't want to talk about points, you want to talk about vectors. So you introduce the vectors A and B. Then they've asked for areas of triangles. We had a formula when we were dealing with vectors in R2 to find areas of triangles. But these are vectors in R3, so that won't help any. Well, we'll go through and find an area of a parallelogram. We had a formula for that. It was only valid in R3 because it used cross products, and cross products are only valid in R3. There's the computations. There's a schematic of the picture. Logic is points to vectors to cross products, norms, and a factor of 1/2 because of the picture.